The talk I have for you for the next half hour is talking about something called electronically assisted astronomy. And this talk is well timed because this application of technology has made this whole event today possible, really. Without having this capability, we wouldn't have been able to provide live views of the sky from our backyard telescopes. So I'm going to talk in a more general sense of what it is that we're talking about and how it works and how you might look into it yourself. So let's consider, if we will, this view of the Orion Nebula. So this is an object that's in the winter sky. I don't know if you can quite see it anymore. It probably sets in the west right around sunset. But this is a simulated view of the best view that I've had of this object through a telescope with my naked eye from a dark sky and using a filter to help improve the contrast, something called an oxygen 3 filter. But what if instead of this view, you could have this view? This is a screen capture from a live viewing session from my backyard here in Ottawa with some light pollution filters installed with a camera. And this is what I am talking about when I say electronically assisted astronomy. So the term itself is sort of an umbrella term, and it captures a lot of different technologies that are available today to assist you with your observing. It includes video astronomy, which is sort of what we're doing today, night vision goggles, short exposure imaging, and near real-time observing are all sort of captured by this one category of astronomy. The idea is that you're using an optoelectronic device to replace your eye as the device that's gathering the light, gathering the actual photons from what it is you're observing. Now, the main objective for EAA is observing, although it is sort of a gray area. It does overlap quite a lot with astrophotography. There are several technologies available, and I'll talk a bit more about those. The technology that you use depends really on how quickly it is you want to see the object. If you want to see it sort of in the sub 1 second time frame, so practically real time, then you would choose night vision goggles. So these are light amplification devices developed originally for military use, but now you can get them available from hunting stores and that sort of thing. If you want something that's more in the seconds to tens of seconds range for how long it takes to get an object, then an analog video camera is sort of what you should be looking at. And there's a number of choices available for that today, starting originally from using security cameras, but they've now evolved from there. After that, if you're thinking, yeah, I can accept it taking tens of seconds to several minutes to get me an acceptable image for observing, then you can look at a digital video camera. So something that, like what I was using today to do my solar observing, can also be used for this application. And some people refer to it as short exposure imaging. So the individual exposures are short, but you're stacking many, many of those frames on top of each other. And then finally, if you don't mind taking tens of minutes to hours to collect your image, then you've moved into traditional astrophotography, which Paul Cloninger was going to talk about after my talk tonight. So the scale moving from left to right in increasing time, it's also increasing in the quality of the image. So the quality of image that you get from a night vision goggle is not going to be anything like what you would get from traditional astrophotography. And there's a range of image quality pretty much paralleling the length of time it takes to get the image. Some of the benefits of using EAA. One is that you can see more of what's in the sky. So this plot on the left compares the spectral response of the human eye when it's dark adapted, that's the blue line, to a typical CCD sensor like you would find in a modern camera, in this case a monochrome camera. And you can see the amount of the spectrum that the camera can detect is much wider than the human eye. The human eye can actually only see quite a narrow part of the electromagnetic spectrum. And I've also drawn on here some wavelengths of light that are useful to us for deep sky objects. The H beta stands for hydrogen beta. That's a certain wavelength of light emitted from hydrogen. Oxygen 3 is the O3. C2 is a emission from carbon that we see often from comets. HA is hydrogen alpha, and then nitrogen 2 and sulfur 2. So these are wavelengths of light we see emitted from nebulae. And you may notice that there's a whole group of these emissions that our eyes can't see at all. That if it wasn't for using a camera, we would have no way of seeing them. So that is a definite advantage of using a camera to gather the light for us. Another advantage is cameras can be much more sensitive than our eyes. We can see things much dimmer than we would with just our naked eyes. Another advantage is we can see in color. So the human eye, when it's dark adapted, is using the rods instead of the cones in our eyes. And as a result, we don't really perceive color very well. We tend to see mostly grays and greens. But a camera can see easily in color in the dark. Another advantage is we can apply filters to make the output from our cameras much better quality. We can use them to get rid of light pollution. We can use them to improve contrast, that sort of thing. There's also many software tools available to help process and enhance the view that you wouldn't have if you were just using your eye. And one advantage that I like is that you can use remote viewing. So for me, I'm sitting comfortably in my basement and I don't really care how cold it is outside or how many mosquitoes there are. I can still observe comfortably regardless of what the conditions are outside. So that is a handy benefit. Another advantage is you can overcome issues with your vision. As you get older, you may have issues with your vision and you're not able to use a telescope with an eyepiece. And so using a camera and putting the image up on a screen can really save astronomy for you. And outreach is also a big area for applying EAA. It's much easier to share an image of an object on a screen where everybody can look at the same time, as opposed to taking turns looking through the eyepiece. So here is a typical EAA setup. This is pretty much exactly what I had set up outside today when we were looking at the sun. So I have, let me get my annotate tool here. So we have a telescope. It's set up on a tracking mount. So this is a motorized mount, so it's able to track the sky. And also I can use the computer in it to point it where I want it to point in the sky. And then in the place of an eyepiece, I put a camera. It's the same interface, just as if you were putting an eyepiece in the scope. The same two interfaces, 1.25" or 2". And then that signal from the camera can go either to a monitor if you just want to look at the video by itself, or if you want to do a little bit more work on the image, you can have that connect to a computer. And from the computer, you can do all kinds of things. You can view the live video, you can control it, you can control your mount, and it is mandatory for a number of the more modern cameras, which are all USB based. Analog cameras, you have the freedom to just go to a monitor, but for the more modern USB cameras, you have to use a computer to see the video. I'll just clear all those annotations. So this is an example of my setup up at the cottage. And the reason that I'm not down on the lovely beach enjoying the fine summertime air is because the mosquitoes there at sunset are terrible. So my setup is actually in a sleep cabin up the hill, and the scope is down on the sand. And all the wires run back up into the building. So that is sort of an example of the sort of setup that you would have. So what do you need to get started in EAA? Well, the first thing you need to have is a telescope. And if you already have a telescope, then you're probably okay to start with what you have. There's no reason to go out and buy anything special. You can do EAA with pretty much any type of scope. To get the most out of it, though, you are going to want a tracking mount. I'm not saying that you couldn't use like a Dobsonian type push-pull, but to really get all of the benefits out of the use of the technology, you should have a tracking mount. Alt-Az type mounts are okay, but again, you get the best tracking from an equatorial mount, so that would be the best choice. But again, Alt-Az is okay. That's what I use now at the cottage. It's just Alt-Az.
Jim?
Yeah.
A question for you from one of the listeners. Do you protect the telescope from blowing sand?
When it's not in use, I do. Yeah, it's covered up when it's not in use, but otherwise I don't. But generally, if it's windy enough that I would need to protect the scope from sand, then I probably shouldn't be observing.
Speed conditions aren't very good.
Not very good. So yes, having a go-to is quite handy if you're doing remote viewing. And for cameras, you have quite a few choices available, and they range quite widely in price. Sort of in the $100, $130 range, all the way up into almost $2,000, depending on the capability of the camera that you want to purchase. And the final thing that you need to have is some way of displaying the video. So if you're using an analog video camera, like this one here, or this one here, you can put the video right into a TV monitor. You don't need to have a computer. You can just watch the video stream separate. Oh, actually, sorry, this one as well. Those are all analog video cameras. And the others are all digital video. They use a USB to connect to a computer. So you must have a computer to view those. Now, you may notice that all of these cameras displayed have the name Malincam on it, and I'll explain that a little later. Clear, move on. Actually, I'll explain it right now. So a large part of the reason why I am active in electronically assisted astronomy has to do with the fact that I live in Ottawa, and also from the Ottawa area is one of the pioneers of electronically assisted astronomy. His name is Rockmelon. He used to be fairly active in the RASC Ottawa Center, but now he lives down in Johnstown. He was one of the first people to experiment with analog video cameras to see what could be done to adapt them to the role of looking at objects in the night sky. He started this back around 1995. And so now he has developed the technology to a point where he has quite a wide spectrum of cameras available. If you want more information about the products that he has, you can go to his website, or you can just go pay him a visit. You know, maybe not right now since we're all on lockdown, but when life is back to normal, you can just go pay him a visit. His shop is in town, and he is more than happy to talk your ear off about video astronomy. Very passionate about that field. So it's my introduction to him that really got me going on the idea of using a camera to do my observing.
So a couple more questions, Jim.
Sure.
How do you get the camera USB video to go over a long cable?
Yes, so the limit on USB on a single cable is 15 feet, but you can connect it to a what's the technical description?
USB hub?
Well, no, it has to be powered. So
Okay.
you can get extension cables that you have an external power source that powers the cable that keeps the voltage level in the USB line up at the required 5 volts. And using that, you can extend the signal quite a long way. So my telescope here is about 60 feet away from my computer, and I have two 30-foot powered extensions in series to bring that signal into my computer. Okay. So that's what I do. Analog video is less restrictive. S-video and the old standard composite video, you can run them at least 100 feet, I think, without having to amplify them. So there are ways of extending it quite long distances. Some people even capture it to computer at the telescope and then connect to it remotely using Ethernet. So there's a number of options available.
Okay, the second question is, are all EAA equipment wired, or are there wireless options?
I'm just thinking. I believe the cameras themselves are all wired. They all have to have interface with some computing device, but there are some systems out there that are sort of standalone computers, you know, the size of like a pack of cigarettes or slightly larger, that will take that signal from the camera and process it and allow you to connect to that device wirelessly. So these are fairly new. There's only a couple of them out on the market so far, but they are starting to become popular, having a device that you connect the camera to that you can then link to wirelessly.
Okay. Thank you.
So talking a bit about my own experiences with EAA, I've been doing it since about 2010. So around the same time I started doing solar system imaging. What really got me into it was a website called Night Skies Network. This is a site started up by Rockmelon, and it is a central site where astronomers from all over the globe can log in and share a live stream from their computer. Similar to what we're doing today, but this is something that runs all year long. And it was what introduced me to the fact that this capability even existed. since that followed the link, that's weird. Okay. So now whenever I observe, pretty much 100% of the time, it's using a camera from my backyard. The convenience of having a setup that's just ready to go, you know, after I've had supper, done whatever chores I need to do. If it's clear skies, then, you know, boom, I'm ready to go. It's really great to have that convenience, and also not have to worry about traveling to a dark site to see anything. The cameras and the filters allow me to get around all those issues. I can honestly say that if it wasn't for EAA, I probably wouldn't be as active in astronomy as I am today, to be frank. To give you an idea of what a session is like, this was captured on the 25th of March. So just over a year ago, and this is from my backyard in the Alta Vista area, where I can see, you know, only a handful of stars at any one time because of the light pollution. So all of these objects were captured on the same night over the course of about 3 hours. Same telescope, same camera. And you can see it's quite a long list of objects. And these are the actual, this is what I saw on the screen. I haven't touched these up or anything. This is just screen captures right off the screen of what I saw through my telescope that evening. So this is the sort of thing that has kept me going in the EAA field. Basically not having any limitations on what I'm able to see from my backyard. And I believe that is the last slide. Yeah. So unless there's any other questions, that's it for me.
Super, Jim, you brought us back on schedule. That's amazing.
You're welcome.
However, we have Paul Cloninger coming up. No, just kidding. We actually do have Paul coming up, and he's going to be talking about astrophotography. Inside joke there.
Yeah.
Sorry about that, Paul. Are you around?
I am indeed. Can you hear me?
Yeah, we can hear you just fine.
Looks
Awesome.
like I got one question. It looks like I can answer.
Oh, yeah. Sorry.
So the camera that was used for that particular observing session was, I think I have it right here. See it, an ASI 294, which is made by that same Chinese company, ZWO. This is a cooled camera. So this is a more expensive camera. I wouldn't buy this for planetary imaging. This is specifically for deep sky imaging. It's in the $1,000 range. There are versions of the same sensor cooled as well, sold by Malencam. So that's also a local option if you want to buy local. And it's equally good performance to that. But that's my favorite color camera for sure.
Okay. Thank you very much.